Okay, let's talk about teeth for a minute. You brush, right?
Twice a day, hopefully.
And floss, maybe.
Sometimes. And maybe use a rinse. Yeah, it's this whole daily thing we do.
It's a ritual, isn't it? We put, actual time and energy into it.
Absolutely. It's like this built-in commitment we all seem to have.
Yeah.
Keeping things healthy in there.
But here's the thing that's, well, kind of frustrating. Despite all that, over 90% of people still get tooth decay.
It's a staggering number when you think about it.
Right. All that effort, the specific paste, the fancy brushes, the floss you feel guilty about not using enough, and the vast majority, still end up needing fillings.
It really does make you pause and think about, well, how effective our current methods really are. Doing the work, spending the money, but the result, it often involves decay. It feels like something's missing.
Exactly. It feels like this cycle. You brush, you try to prevent, but problems pop up anyway.
Today, we're looking at something that could really revolutionize trips to the dentist. We're talking about the amazing progress in regrowing human teeth.
Yeah, it's fascinating stuff.
Forget just, patching things up with fillings or replacing them with implants. The future might actually hold truly biological replacements.
And healing damage in ways we haven't really seen before.
You know that feeling when you leave the dentist? With a new filling. The whole surgery thing?
Yeah, it's not exactly comforting, is it? Even with modern dentistry, those solutions they feel like interventions, not really cures. They have trade-offs.
Exactly. Compromises. We're basically patching things up with artificial stuff.
Right.
And that's why this research we're looking at today is so fascinating. What if we didn't have to patch? What if we could actually regrow?
That's the million-dollar question.
Really groundbreaking work from King's College London. And how could growing teeth in a lab, change everything?
Right, moving from just repair to actual regeneration. That's the core idea.
Okay, so let's start with the familiar problems. Fillings. Over time, it can actually weaken the whole tooth structure.
And they wear out.
They don't last forever, so you're back in the chair, maybe more decay has crept in, or you get that awful sensitivity.
It's a mechanical fix for a biological problem, really. And implants, while they replace the tooth, it's invasive surgery.
Multiple appointments, not quick.
Not at all. And there are risks, infection, maybe damage to the teeth next door or the gums. It's a big deal.
Okay, so current options have clear downsides. Which brings us to the exciting part, lab-grown teeth. The basic idea, growing a replacement tooth from your own cells in a lab. Sounds wild, almost sci-fi.
It does. But the potential benefits are grounded in real science. Think about it. If it's grown from your cells, your body is much less likely to reject it. Implants have about a 5 to 10% rejection rate. With a tooth from your own cells, that risk could potentially just disappear.
And stronger than fillings, presumably.
That's the expectation, yes. Stronger, longer lasting. But the real game changer.
Let me guess. It actually integrates like a real tooth.
Exactly. It could regenerate naturally, integrate right into the jawbone. It would function just like the real thing.
That sounds like the holy grail for dental treatment, doesn't it? A truly sustainable solution.
It really does. It's a total shift in thinking.
So how are they actually doing this? Let's get into the science bit. How do teeth normally develop?
Well, it's this incredibly complex dance, really. Stem cells are the key players. They talk to each other using special signals, these signaling molecules.
So little messengers?
Kind of, yeah. They tell the stem cells what to become, the hard outer enamel, the dentin underneath, the cementum that anchors the root. It's all orchestrated by these signals.
And humans, we get our baby teeth, then our adult teeth, and that's it. Unlike sharks.
Right. Sharks, crocodiles, they keep their tooth-making stem cells active throughout life. They can just keep regenerating teeth.
Why can't we?
We basically lose those specific active stem cells once our adult teeth are fully formed. The regenerative potential just isn't there anymore for making whole new teeth.
Okay, that makes sense. So if our bodies can't do it, how are the scientists managing it in the lab? What's the big breakthrough?
The breakthrough is this special material they developed, a hydrogel. This hydrogel creates the right environment, like a scaffold, for the cultured cells, the ones derived from stem cells, to communicate. It mimics the natural environment in the body, the matrix around the cells.
So it's like creating the perfect little neighborhood for the cells to chat and build a tooth.
That's a great way to put it. And it's not just a passive scaffold. Previous attempts often released all those signaling molecules, those instructions, way too quickly.
Like shouting all the instructions at once.
Exactly. Information overload. The cells couldn't follow the steps properly.
So this new hydrogel,
It releases the signals slowly, gradually, over time. It carefully mimics that natural step-by-step process of how a tooth actually develops in the jaw. That controlled release is the key innovation.
that's really clever, guiding the cells step by step. So where are they now? Are we close to getting these in the dentist's office?
Right now, they're focused on figuring out the best way to get these lab-grown teeth into the mouth safely and effectively.
Makes sense. What are the options they're considering?
Two main ideas. One is transplanting very young tooth cells, like tooth buds, into the empty spot and letting them finish growing right there in the jaw.
Grow it in place.
Right. The other idea is to grow the whole tooth, or most of it, in the lab first, and then surgically implant the finished product.
Interesting. Two different strategies.
Yeah, and both need more research to figure out which is better, safer, more reliable.
It feels like we're really watching medicine evolve here. You mentioned this fits into a bigger picture.
Oh, absolutely. This is a fantastic example of regenerative medicine. The whole field is moving towards using our own biology to repair or replace damaged parts, moving away from purely artificial materials like metals or plastics.
Using biology to fix biology.
That's the essence of it. Lab-grown teeth are a really powerful illustration of where this could lead.
So let's bring it back to her. Maybe someone who's just had a filling or is facing an implant decision. Why does this lab work in London matter to them right now?
Because it represents hope for a fundamentally better way. Imagine a future where dental work isn't about constant repairs or worrying about implant failure. Lab-grown teeth could mean a truly natural, potentially permanent solution. Something that lasts, integrates perfectly, and avoids the downsides of surgery or fillings weakening the tooth. It could end that cycle of repair and replacement.
That's the real aha moment, isn't it?